Assalamu alaikum. Today we will learn about the binomial distribution. Binomial distribution is for the discrete variable. What is a discrete variable? We will recall the concept. The quantities which we can count are known as discrete variables. Just like number of kids, number of bolts, number of ACs, number of students are examples of discrete variable. What is a continuous variable? The quantities which we can measure are known as continuous variable. Examples are time, length, volume. We measure all these things. We measure the time, we measure the length. So these are continuous variable. Binomial distribution is for the discrete variables. Now, I will elaborate this concept with the help of an example. The question is, draw the probability distribution for the number of sixes when three paired dice are rolled. I will extend the concept of probability distribution to the binomial distribution. First of all, I will define the probability distribution. Then we will extend the probability distribution. We will extend. I will give you the idea about the binomial distribution on the basis of probability distribution. To find out all the possible outcomes, I will draw a tree diagram. 6 is the requirement. I will combine all other outcomes. The probability of 6 is 1 by 6 and not 6 is 5 by 6. Now again, for the second experiment, for the second die, I will draw 2 branches. For the third experiment, again, I will draw 2 branches, 6 not 6, 6 not 6, 6 not 6. So the possible outcomes are 6, 6, 6, 6, 6, not 6, 6 not 6, 6, 6 not 6, not 6, 6 not 6 and 6, 6 not 6, 6 not 6 not 6 not 6, 6 not 6 not 6 not. Now the number of sixes are 3, 2, 2, 1, 2, 1, 1, 0. So the different values for the variable, that is number of sixes, is 0, 1, 2, and 3. The probability for x is equal to 0 is 5 by 6 into 5 by 6 into 5 by 6. That is 5 by 6 cube. The probability for x is equal to 1 is x is equal to 1 is 5 by 6, 5 by 6, and 1 by 6. And there are 3 ones. So the probability of 3 ones is 3 into 5 by 6 square into 1 by 6. The probability of 2 is there are 2 sixes and 1 not 6. That is 5 by 6 into 1 by 6 power 2. And there are 3 outcomes. All outcomes have the same probability. So we will multiply the probability of 2 sixes, one outcome, with 3. Probability of 3 sixes is 1 by 6 cube. This one is the probability distribution when 3 for the number of sixes when 3 fair dice are rolled. Now, if this experiment satisfies the following 4 conditions, then the probability distribution is known as binomial distribution. Number 1, condition number 1 is experiment is repeated for a fixed number of times. Experiment is repeated for a fixed number of times. Yes. In the above question, the dice is rolled thrice. So yes, the experiment is repeated for a fixed number of times. That is 3. Now, the second condition is experiments are independent. Yes, the experiments are independent. If there will be a 6 on in the first row, there will be a 6 on the first row or not. It doesn't depend that there is a 6 in the previous experiment. 6 in one experiment doesn't affect the probability of 6 in the next experiment. Yes, the experiments are independent. If there is a not 6 in the first experiment, there may be a 6 in the next experiment. There may not be a 6 in the first experiment. The result of second experiment is not independent of the first one. Number three, probability of success remains the same throughout. Yes, the probability of success in the first experiment is 1 by 6. In the second experiment is 1 by 6. In the third experiment is 1 by 6. 4. There are only two outcomes. Pass or fail. Yes or no. Yes. In the above question, there are only two outcomes. There will be a 6, there will be not a 6. If a experiment satisfies these four conditions, then the experiment is known as binomial distribution. Binomial distribution is written in the form X is a binomial distribution with n comma p, where n and p are the parameters of the distribution. Of the binomial distribution. Now, what is n and what is p? N is the number of experiments. In the above example, there are three experiments, so n is equal to 3, and p is the probability of success. In the above experiment, the probability of success is 1 by 6. So for the above question, we will write down the binomial distribution like this. X is a binomial distribution. N is 3, number of experiment, and the probability of success is 1 by 6. In the binomial distribution, There is no need to draw any diagram to find out all the possible outcomes. In the binomial distribution, there is a probability density function. With the use of this probability density function, we can calculate the probabilities of the different outcomes. Probability of x is equal to x is equal to NCR P raised to R and Q raised to N minus R. Now, R is the number of successes, N is the number of experiments, P is the probability of success, Q is the probability of failure. And Q is equal to 1 minus P. Now for the above experiment, we will find out the probabilities of all the outcomes, that is x is equal to 0, x is equal to 1, x is equal to 2 and x is equal to 3 with the help of this probability density function. For the above experiment, x is a binomial distribution with 3, 1 by 6. Now we want to find out the probability when x is equal to 0. X is equal to 0 means there is no 6. There is 0 success. So here R is equal to 0. R is the number of successes. So in this case, R is equal to 0. We will put all these values in the probability density function. Here we have NCR, NCR, NCR. N is 3, R is 0. Probability of success is 1 by 6 and P power R, that is 1 over 6 power 0. And Q power, Q is 1 minus P 1 minus 1 by 6 is 5 by 6. 5 by 6 power n minus r, 3 minus 0, that is 3. 5 by 6 power 3. Now we will find out probability of x is equal to 1. 3C1, there is one success, so 1 by 6 power 1, and there are two failures, 5 by 6 power 2. 3 into 1 by 6 into 5 by 6 power 2. Probability of x is equal to 2. 3C2, there are two successes, 1 by 6 power 2 and 5 by 6 power 1. 3C2, 3, 1 by 6 power 2 and 5 by 6 power 1. Probability of x is equal to 3. That is, there are three successes. There are three successes. 3C3, three successes, success power 3, and 0 failure. So 5 by 6 power 0. The final answer is 1 by 6 power 3. Now, with the help of this formula, we can find out the probabilities of all the possible outcomes. Now, how can we find out the probability mean and the variance for the probability distribution? The formula for the mean is sum x into p of x. Mean is also known as expected value of x. We will generate two columns. We will generate one column x into p of x, and the sum of this column is the mean of the probability distribution. Now variance of x is equal to expected value of x square minus expected value of x whole square. Mean of squares minus mean square. Expected value of x square is sum x into p of x minus sum expected value of x square is sum x square into p of x minus sum x into p of x whole square. We will generate another column x square into p of x. We will find out the sum of these two columns and we will put the values into the formulae. These two formulae to get the mean and the variance of the probability distribution. Now, in a binomial distribution, there is no need to generate these two columns. The mean of the binomial distribution is NP. Simple. And variances of the binomial distribution is NPQ. Now, for the above question, the mean is N is 3, P is 1 by 6, mean is 1 by 2. And the variance is N P Q. That is 5 by 12. Now, it is very easy to calculate the mean and the variance in the binomial distribution. So, we will have to memorize this probability distribution formula and the formula for the mean and the variance. Now we will attempt some questions to practice this concept of binomial distribution. Exercise 5b is about the binomial distribution. This exercise is from concise course A levels by J. Crosha and J. Chambers. Now, question number 1 is 30% of pupils in a school travel to school by bus. Now, the variable is pupils, students. Students is a discrete variable. To find the number of students, we will from a sample of 10 pupils chosen at random, find the probability that only 3 travel to school by bus, less than half travel to school by bus. Exercise 5b, question number 1. Now, first of all, we will write down the definition of this binomial distribution. The definition of the binomial distribution is X is a binomial distribution with n comma p. X is a binomial distribution from a sample of 10. The total available students are 10, and the probability that he will travel to school by bus is given, that is 30%, that is 0.3. This one is the definition of the binomial distribution. First of all, we will write down this definition in all the questions, whether it is a normal distribution, whether it is a binomial distribution, whether it is a geometric distribution. First of all, we will write down the definition of the binomial distribution. Now, A part is only 3 travel to school by bus. That is, we need 3 successes out of 10. Probability of X is equal to 3. Now, NCR, the formula is NCR P raised to R Q raised to N minus R. N is 10. 10C, we need 3 successes. There are 3 successes, so 0.3 power 3. And there are 7 failures. The probability of Q is 1 minus P, that is 1 minus 0.3 is equal to 0.7. And its probability is this. Now, we will put whole of this expression into the calculator to get the final answer. Now, the B part is less than half travel to school by bus. Less than half means half is 5, less than half. Probability of X is less than 5. Now, there may be 0 success, there may be 1 success, there may be 2 successes, there may be 3 successes, and there may be 4 successes, but not more than 4. Less than half means x is less than 5. Now we will find out the probability for x is equal to 0 with the help of probability density function. Now nc0, 10c0, 0.3 power 0 and 0.7 power 10. For x is equal to 1, 10c1, 0.3 power 1 and 0.7 power 9. For x is equal to 2, 10c2, 0.3 power 2 and 0.7 power 8. For x is equal to 3, plus 10c3, 0.3 power 3 and 0.7 power 7, plus 10c4, 0.3 power 4 and 0.7 power 6. Now we will put whole of this expression into the calculator and get the final answer. There is no need to calculate the probability separately and then um, adding the probabilities. Just put the whole expression in the calculator to get the final answer. Now there is a C part. The C part is find the probability that there is at least one success. That at least one student travel to school by bus. One student. So we want to find the probability, that probability of x is greater than equal to 1. Greater than equal to 1 covers probability of x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it is very difficult to find out all the probabilities for x is equal to 0, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I will try to simplify this one. That is, the total number of outcomes are, I will write down all the possible outcomes. That is, probability of x is equal to 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus probability of 6, plus probability of 7, plus probability of 8, plus probability of 9, plus probability of 10. These are all the outcomes of this experiment, and sum of all the outcomes is equal to 1. Now we want to find the probability of all these numbers. Okay, we will write down all these numbers like this. Probability of x is equal to 0 plus probability of x is greater than equal to 1 is equal to 1. So probability of x is greater than equal to 1 is equal to 1 minus probability of x is equal to 0. So if we will find out the probability of x is equal to 0 and subtract the answer from 1, then we will get the probability of x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We will use this shortcut method to find out the probability for x is equal to 1. So 1 minus probability of x is equal to 0, nc0, that is 10c0, p power 0, 0 success, and there are 10 failures. We will put this expression into the calculator and we'll get the final answer. Now, question number 8. Question number 8 is, assuming that a couple are likely are equally likely to produce a boy or a girl. Find the probability that in a family of 5 children, there are more boys than girls. Total number of experiments are 5. X is a binomial distribution with 5 comma. There are more girls than boys. We will consider boys as a success. The probability of producing a boy is 1 by 2. So this one is the binomial distribution. This one is the definition of the binomial distribution. There are more boys in 5. So we want to find out the probability that is x is greater than equal to 3. If there are out of 5, if there are 3 boys, then boys are more. If there are 4 boys, then there are more boys. And if there are 5 boys, then there are more boys than girls. Now we will find out the probability of x is equal to 3. 5c3, n is 5, 5c3. There are 3 successes. The probability of success is 1 by 2. And the probability of failure is 1 minus 1 by 2, again 1 by 2 is 2. Plus 5c4, 1 by 2 power 4, 1 by 2 power 1, plus 5c5, 1 by 2 power 5 and 1 by 2 power 0. We will put this expression into the calculator to get the final answer. Now we will attempt question number 10. Question number 10 is, Charlie finds that when she takes a cutting from a particular plant, the probability that roots it roots successfully is 1 by 3. She takes 9 cuttings. Find the probability that more than 5 cuttings root successfully. 9. Total number of experiments are 9 and the probability of success is 1 by 3. X is a binomial distribution with 9 comma 1 by 3. More than 5 cuttings. For A part, number 1, probability of x is greater than equal to 5, more than 5, not equal. Simple probability of x is greater than 5. That is probability of x is equal to 6 plus probability of x is equal to 7 plus probability of x is equal to 8 plus probability of x is equal to 9. The formula is NCR, that is 9C6, 1 by 3 power 6, and the probability of failure is 1 minus 1 by 3, 2 by 3 power 3, plus 9C7, 1 by 3 power 7, and 2 by 3 power 2, plus 9C8, 1 by 3 power 8, and 2 by 3 power 1, plus 9C9, 1 by 3 power 9, and 2 by 3 power 0. We will put this expression into the calculator to get the final answer. Now part number 2 is at least one cutting route successfully. At least one. It means we want to find out probability of x is greater than equal to 1. The total number of outcomes are 0, 1, 2, 3 up to 9. If we will, the x is greater than 1 covers 1 till 9. There is only one outcome which is not included, that is x is equal to 0. We will subtract the probability of x is equal to 0 from 1 to get the probability of x is equal to 1 plus 2 plus 3 plus 4 up to so on plus 9. So 1 minus, for x is equal to 0, 9C0, 1 by 3 power 0, and 2 by 3 power 9. This one is the answer to part number 2. Now part B of question number 10. Find the number of cuttings that should take in order to be 99% certain. Find the number of cuttings. That is, we want to find out the number of cuttings planted. We want to find out the n that she should take in order to be 99% certain that at least one cutting route successfully. One cutting, at least one. Probability of at least one is probability of x is greater than equal to 1. Now, in this case, we will write down the definition first. X is a binomial distribution, n is unknown, while the probability of success is given, that is 1 by 3. He should be 99% certain, that is the probability is 99%. Probability is 99%. We will write down probability of x is greater than equal to 1 is equal to 0.99. That at least one cutting will root successfully. Now, how can we handle probability of x is equal to 1? We will write down this one. 1 minus probability of x is equal to 0 is equal to 0.99. 1 minus 0.99 is equal to probability of x is equal to 0. 0.01 is equal to, for the probability x is equal to 0, NC0, n is unknown. Probability of success is 1 by 3, there is 0 success, so power 0, and q, which is 2 by 3, has power n. Now 0.01, NC0 is 1. 1 over 3 power 0 is 1. So there is only 2 by 3 power n. Now, whenever power is unknown, we will use logarithm to find out the unknown power. Whenever the power is unknown, we will use logarithm to find out the unknown power. We will write down log on both sides. Now, there is a very important rule of logarithm. That is, we can write down the power as a coefficient. We can write down the power as a coefficient. If there is log m power n, we can write down n log n. M is known as the argument. Here, m is known as the argument. M is known as the argument, and the argument has the power n. Now, the power of the argument can be written as a coefficient. We will use this rule in this question, that is log of 0.01 is equal to n log of 2 by 3. Now we will find out the values of log of 0.01 and log of 2 over 3 with the help of calculator. Log, this one is -2, and log 2 by 3 is minus 0.176. The value of n is 11.36. Now, if we will take 11.36, if the value of n is 11.36, then the probability is 0.99%. And if we will take 11, the probability will be less than 99%. We should be 99% confident. So we will take n is equal to 12. If we will take n is equal to 11, then the probability will be less than 99%. So we will take n is equal to 12. Now we will attempt question number 15. Question number 15 is, the probability that a target is hit is 0.3. The probability of success is 0.3. Find the least number of shots. We want to find out n. We want to find out the number of experiments which should be fired. Question number 15. X is a binomial distribution with n comma 0.3. Now, again we will read the question. The probability that a target is hit is 0.3. Find the least number of shots which should be fired if the probability that the target is hit at least once. Probability of x is greater than equal to 1, at least once, is greater than, the probability is greater than 0.95. State any assumption that you have made. The assumption I have made is that the probability of success remains the same throughout. The probability of hitting the target is 0.3 all the times. The probability of hitting the target in each turn is 0.3. Now, how can we deal probability of x is greater than equal to 1? 1 minus probability of x is equal to 0 is greater than 0.95. Probability of x is equal to 0, 1 minus 0.95. 0.05 is greater than nc0, n is unknown, c0. Now there is 0 success and the probability of success is 0.3. So 0.3 power 0. Probability of failure is 1 minus 0.3, that is 0.7 power n. Now 0.05, nc0 is 1, 0.3 power 0 is 1, and 0.7 power n. Now you can see that the power is unknown. To find out the power, we will use the log. We will apply log on both sides to find out n. Log 0.05 is greater than log 0.7 power n. We will write down the power of the argument as a coefficient, that is n log 0.7 log 0.05. The value of log 0.05 is minus 1.301 and the value of 0.7 is minus 0.155. Now when we will divide both sides with minus 0.155, we'll have to change the sign of the inequality, because this one is a rule of the inequalities, that is, if we will divide or multiply the inequality with a negative number, we will have to change the sign of inequality. N is greater than 8.39. N is greater than. Now, the values of n may be 9, 10, 11, 12, up to so on. But in the question, it is the requirement, find the least value for the number of shots. Find the least value for the number of shots. So the least value is n is equal to 9. This one is question number 15. Now, we will attempt question number 5.17. Example number 5.17 is, this one is about how can we find out the mod of the binomial distribution. Now, what is mod? How can we define mod? Mod is the most occurring number having the highest frequency, or mod is the number having the highest probability. Now, as you know that binomial distribution is for the discrete variable. Now, in question number 5.17, example number 5.17, I will read the example. The probability that a student is awarded a distinction in mathematics examination is 0.05. Probability of distinction is given. In a randomly selected group of 50 students, what is the most likely number of students awarded a distinction? Now, the total number of students available are 50. X is a binomial distribution with n comma b, 50 comma 0.05. Now, as you know that the measure of center tendency is mean, median, and mode, and they are adjacent to each other. They are very close to each other. Mean, median, and mode are close to each other, nor most of the time close to each other. Now, first of all, we will find out the mean of this distribution. The formula for the mean of the distribution is expected value of x is equal to np. 50 into 0.05 is equal to 2.5. So the Mod is mean is 2.5. Mod is also close to 2.5. Now we will check the probability for the values of x in the neighborhood of 2.5. In the neighborhood of 2.5, there is x is equal to 2 and x is equal to 3. इसके जो करीब 3 values हैं उनको हम check करेंगे. Now we will find out the probability for x is equal to 2. Suppose that if the mean is 7.8, then we will check the values x is equal to 7 and x is equal to 8. The probability of the values x is equal to 7, x is equal to 8. In this question, the mean is 2.5 and mod is close to 2.5. We will check the values in the neighborhood. That is, we will check x is equal to 2. NC for x, for the probability x is equal to 2, NCR 50C, number of successes is 2, probability of success is 0.05 power 2, and the probability of failure is 1 minus 0.05, that is 0.95 power 48, and the answer is 0.261. We will check probability of x is equal to 3, 50C3, 0.05 power 3 and 0.95 power 47 is equal to 0.219. Now, which number has the greater probability? X is equal to 2 has the greater probability. So, x is equal to 2 is the mod of the distribution. Now, the link of this exercise is given in the description. You can download the exercise and attempt questions from this exercise. Thank you.